All right, so today we're going to be diving into something that's pretty crucial in today's world: messaging systems. You've asked for a deep dive into Apache Pulsar and Kafka, and from your sources, it looks like we're going to be getting in some seriously in-depth technical stuff here.
Yeah, we certainly are. And you know what's so interesting about these systems is that they're handling data on a scale that most people can't even imagine. I mean, we're talking the kind of data fire hose you see at companies like Facebook or China Mobile, with billions of events happening every single day.
Yeah, it's mind-boggling, and we've got documentation for both Pulsar and Kafka. So we'll get into those technical details straight from the source. But before we get lost in the weeds, maybe we can start with the basics. Like, what exactly is a messaging system?
Well, think of it as a really efficient postal service. But for data instead of letters, we have producers creating messages, which could be anything from user activity on a website to sensor readings from a device. These producers send their messages to brokers, which you can imagine as the sorting offices.
Okay, I'm starting to get the picture. So the brokers are like the middlemen, making sure the messages get delivered to the right place.
Exactly. And on the receiving end, we have consumers, applications that need this data. They subscribe to specific topics, kind of like choosing which magazines you want to receive. And the brokers deliver only the messages that match those subscriptions.
Makes sense. So both Pulsar and Kafka are doing this messaging thing, but they're taking different approaches, right?
Yeah.
And you mentioned earlier the huge amount of data these systems handle. What makes them capable of operating at that scale?
Both are designed from the get-go to handle massive scale, processing terabytes of data every day. That's what makes them so powerful and essential in today's data-driven world. But the way they achieve that scale, that's where the interesting differences come in.
Let's get into those differences then. Starting with the architecture, it looks like Pulsar is using something called Apache BookKeeper. What's that all about?
You could say BookKeeper is Pulsar's secret weapon. It's a completely separate system dedicated solely to storing messages. This gives Pulsar a ton of flexibility and scalability because the storage can grow independently of the brokers that handle the actual processing of the
So
messages.
it's like having a separate warehouse just for storing all those messages,
Yeah.
freeing up the brokers to focus on the delivery side of things.
Precisely. And this decoupling of storage and processing is a key design element of Pulsar. It's like a well-organized company with specialized departments. Now, Kafka takes a different route. Instead of a separate system for storage, Kafka stores messages directly on the brokers themselves.
So it's a more integrated approach, keeping everything under one roof. Is there a benefit to doing it that way?
While the benefit is simplicity, by keeping things together, Kafka can optimize the flow of data from producers to consumers. There's less overhead, potentially leading to a performance boost, but as you might guess, it puts more demands on the brokers themselves.
That makes sense. So it's like choosing between a streamlined all-in-one printer or having separate devices for printing, scanning, and faxing. Each approach has its advantages and drawbacks. So when it comes to Pulsar's decoupled architecture versus Kafka's integrated one, which is better?
That's the million-dollar question, isn't it? And the answer, as you might suspect, is that it depends. It depends on your specific needs, priorities, and what you value in a messaging system. If you need extreme flexibility and the ability to scale storage independently, Pulsar with BookKeeper might be a good fit. But if you prioritize simplicity and raw performance, Kafka's integrated approach could be more appealing.
Yeah, it seems like we're already seeing a theme here. There's no one-size-fits-all answer when it comes to choosing between these systems.
Absolutely. And that's what makes this deep dive so fascinating. It's not about declaring a winner, but rather understanding the strengths and trade-offs of each approach.
All right, so we've got a good grasp on the overall architecture, but I'm curious about some of the specific features that set these systems apart. In the Pulsar documentation, they talk about multi-tenancy. What exactly does that mean?
Multi-tenancy is like having different apartment buildings within your messaging system. Each tenant, or team in this analogy, gets its own isolated space, with its own security and resource allocation. This helps keep things organized and prevents one tenant's activity from impacting others.
So you could have multiple teams within a company,
Right.
each using Pulsar for their own projects, without stepping on each other's toes.
That's exactly it. And
Okay.
this built-in multi-tenancy is one of Pulsar's key strengths. It makes it a natural fit for organizations with diverse teams and projects, all needing to share the same messaging infrastructure.
That's a powerful feature. Does Kafka have anything similar?
While Kafka doesn't have native multi-tenancy in the same way Pulsar does, it can be achieved through careful configuration and management practices. It's more of a DIY approach, requiring additional effort and expertise.
Interesting. So it's possible with Kafka, But it's not as straightforward as with Pulsar.
Precisely. And this highlights another key difference in design philosophy. Pulsar was designed from the ground up with multi-tenancy in mind, whereas with Kafka, it's more of an add-on.
Makes sense. Now I'm also seeing something about consumer groups in the Kafka documentation. How does that work?
Consumer groups. They are a brilliant way to boost efficiency and parallelize processing. Think of it as a team of friends working together to tackle a giant pizza.
Okay, I'm intrigued. How does the pizza analogy relate to data processing?
Well, imagine the pizza is a large data set that needs to be processed. If you have one person eating the pizza, it's going to take a while. But if you have a group of friends sharing the slices, it gets done much faster.
So in the Kafka world, a consumer group is like a team of consumers, each tackling a portion of the data.
Exactly. And Kafka's load balancing algorithm ensures that the workload, or the pizza slices in our analogy, are evenly distributed among the consumers in the group. This ensures that no single consumer gets overwhelmed and the processing happens quickly.
That's clever. So both Pulsar and Kafka have ways of distributing the workload. But they go about it in different ways. Pulsar with its multi-tenancy, separating things at a higher level, and Kafka with its consumer groups, dividing the work within a topic.
You've got it. And this just goes to show that there are multiple ways to skin a cat, so to speak, when it comes to designing a messaging system.
And both systems seem to be doing a pretty good job of it, judging by their popularity and widespread use. But let's not forget, we also have some juicy performance benchmarks from the Kafka documentation. They actually put Kafka head-to-head against ActiveMQ and RabbitMQ, two other popular messaging systems.
Yes, those benchmarks are quite revealing, and they point to one of Kafka's key strengths, raw performance.
So they tested both producing and consuming millions of messages.
Exactly. And they looked at how quickly messages were sent by producers and how quickly they were processed by consumers.
And the results.
Well, the results are pretty interesting. Kafka showed a significant performance advantage, especially in terms of handling high message volumes. This points to the strength of its design. But remember, benchmarks don't always tell the whole story.
Right. There's always more to it than just raw numbers. But it's still impressive to see those performance gains, especially if you're dealing with data at scale. And speaking of performance, I noticed Kafka's documentation mentions the use of something called a send file API. What's the significance of that?
The send file API. It's a clever trick that Kafka uses to speed up the transfer of data. Instead of copying data multiple times between different memory buffers, which can be slow and inefficient, send file allows for a direct transfer of data from the disk to the network.
So it's like cutting out the middleman in the data transfer process, reducing the number of steps involved. That makes sense. And it seems like Pulsar has its own performance optimization tricks up its sleeve, something about avoiding double buffering.
Exactly. Pulsar tries to eliminate unnecessary copying of data between buffers, which can also improve efficiency. So both systems are paying close attention to these low-level details that can make a big difference in overall performance.
Yeah, it's fascinating to see how much thought goes into optimizing these systems for speed and efficiency. And I'm sure these optimizations are crucial when you're handling the kind of data volumes that Pulsar and Kafka are designed for. But let's step back for a second and talk about real-world use cases. Where are these systems actually being used out there in the wild?
Well, both Pulsar and Kafka have found their way into a wide range of industries and applications. Pulsar, with its flexibility and multi-tenancy, is often a favorite for real-time analytics, financial transactions that need to be processed instantly. And the world of IoT data, where millions of sensors are constantly sending data. In fact, the stock ticker example from Pulsar's documentation is a perfect illustration of how it handles real-time data streams.
Right, it's all about getting the data where it needs to go as quickly as possible. Now, what about Kafka? Where does it shine?
Kafka has become almost synonymous with log processing. Think analyzing website traffic or application logs, stream processing, where data is analyzed in real time as it flows through the system, and building those complex data pipelines that power modern businesses.
Oh, and remember that anecdote about LinkedIn using Kafka to process billions of events per day. That data fire hose helps power their website features, making connections, suggesting jobs, all in real time.
Exactly. And that highlights just how crucial these messaging systems are. They're the unsung heroes behind so many of the applications and services we use every day.
It's amazing to think that something as seemingly mundane as message passing can have such a profound impact on the world around us.
It truly is. But like any technology, there are limitations and trade-offs to consider.
The reality check. I was wondering when we'd get to that. What kind of limitations are we talking about?
Well, for instance, at the time the Kafka paper was written, it didn't have built-in replication.
Wait, no built-in replication? That seems like a pretty big deal for a system that's supposed to be so reliable.
It was, and they've since addressed that limitation. But it highlights a key point: every system makes trade-offs. In Kafka's case, the initial focus was on performance and simplicity. Replication adds complexity, potentially impacting those aspects.
So it's a balancing act. You can't have everything all at once. Now, what about Pulsar? What are some of its limitations? Sounds like it could be more complex to manage with that separate bookkeeper system.
That's a valid consideration. Decoupling storage offers advantages, but it also introduces management overhead. You need expertise in both Pulsar and BookKeeper to run the system effectively.
So there's a trade-off there as well. More flexibility and scalability come with increased complexity.
Exactly. And this is why it's so important to understand the nuances of these systems. There's no single best messaging system. It all depends on your specific needs and priorities.
I love these deep dives. We get to see the nuance, the trade-offs, the behind-the-scenes decisions that shape these technologies.
Yeah.
It's not just about fanboyism. It's about understanding what makes these systems tick.
Precisely. And that understanding empowers you to make the right choice for your specific use case. There's no single winner in this messaging showdown.
Well said. Now, we've established that both Pulsar and Kafka are heavy hitters in the messaging world, and we've touched on some key differences. But I'm curious, are they really that different?
That's a great question. On the surface, they might seem similar. They both handle messaging. They're both open source. They both scale. But if we dig deeper, what's crucial to grasp is that Pulsar was designed from the ground up with multi-tenancy in mind. Think of it as a built-in feature woven into the fabric of the system. This makes it a natural fit for organizations with multiple teams or departments, all needing to share the same messaging infrastructure securely and efficiently.
Like having designated lanes on a highway, keeping traffic flowing smoothly even during rush hour.
An apt analogy, and it's not just about organization, it's also about isolation. One tenant's activities don't impact another, ensuring stability and predictability.
So where does Kafka fit into this multi-tenancy picture?
While Kafka doesn't have native multi-tenancy, it can be achieved through careful configuration and management practices. It's more of an add-on requiring additional effort and expertise.
Okay, so multi-tenancy is a key differentiator. But what about the way they handle message persistence? That seems pretty fundamental to any messaging system.
Absolutely. Both systems guarantee message durability, but they take different paths to achieve it. Pulsar leverages Apache BookKeeper, which uses a sophisticated consensus protocol based on quorum writes and reads.
Quorum writes and reads. Could you break that down for us? It sounds a bit complicated.
It might sound complex, but it's all about ensuring data consistency and preventing data loss. Think of it as a safety net for your messages to make sure data is safely stored. BookKeeper requires a certain number of bookies, the storage nodes, to acknowledge that they've received and stored the data. This quorum ensures that even if some bookies fail, the data is still safe.
So it's like having multiple backups. So even if one copy gets damaged, the others are still intact.
Exactly. Now, Kafka takes a different approach, relying on its simple storage layout and efficient transfer mechanisms. Messages are appended to segment files, which are flushed to disk periodically.
And we talked about how Kafka avoids explicit message caching, instead relying on the operating system's page cache. That seems like a clever way to simplify things and improve performance.
Indeed. Kafka's design philosophy often favors simplicity over complex mechanisms, which contributes to its reputation for robustness and performance.
Okay, so Pulsar relies on a separate system for persistence and sophisticated consensus protocols, while Kafka focuses on a streamlined, integrated approach. It's fascinating to see these different design philosophies in action.
And remember, there's no right or wrong here. It all depends on your specific needs and priorities. Are you comfortable managing a more complex system like Pulsar with BookKeeper? Or do you prioritize the simplicity and performance of Kafka's integrated approach?
These are the tough questions that keep data architects up at night.
But with the knowledge we've gained in this deep dive, you're well equipped to make those decisions confidently.
This has been really helpful in getting a better understanding of how these systems work. I'm really starting to appreciate the different approaches they take, but there's still so much to unpack.
Absolutely, and we've only just scratched the surface. There's a whole world of fascinating details waiting to be explored.
Well, let's keep exploring that. I'm ready for more. Okay, so last time we left off talking about how both Pulsar and Kafka have really different approaches to message persistence. You mentioned that Kafka's design tends toward simplicity. Does that carry over into other parts of the system?
Absolutely. It's a recurring theme in Kafka's design. For instance, let's look at how it handles load balancing.
Okay, load balancing. Now that sounds important. What exactly does that mean in the context of messaging systems?
Load balancing is all about making sure the workload is evenly distributed across the system. Imagine you have a team of workers, and you want to make sure no one is overloaded while others are sitting idle. It's the same idea with messaging systems.
So you don't want one broker or consumer getting slammed with traffic while others are twiddling their thumbs.
Exactly. That kind of uneven distribution can lead to bottlenecks, slow performance, and even system failures.
Okay, so load balancing is crucial. How does Pulsar handle it?
Well, Pulsar leverages its decoupled architecture. Remember BookKeeper. The separation of storage and serving plays a key role here. At the bookkeeper level, message segments are spread across all the bookies. So even if one bookie gets overloaded, the others can pick up the slack.
It's like having multiple checkout lanes at a supermarket. Even if one lane gets backed up, the other lanes can keep things moving.
Right. And at the broker level, Pulsar has automatic load balancing. It constantly monitors how busy each broker is and redistributes topic sessions as needed.
So it's constantly adjusting to make sure things are running smoothly. Yeah. Now, how does Kafka approach load balancing?
Kafka also uses a dynamic load balancing approach, but it ties in closely with consumer groups. Remember how we talked about those groups dividing up the workload?
Yeah, like sharing slices of a giant pizza.
Well, Kafka's load balancing algorithm ensures those pizza slices, or data partitions, are distributed evenly among the consumers in the group.
So it's not just balancing the load across brokers, but also across the consumers within a group. That's a pretty neat trick.
It is, and this two-level balancing ensures messages are processed efficiently and no single broker or consumer gets bogged down.
Yeah, it's amazing how these systems work behind the scenes to keep everything running smoothly, even when handling such massive amounts of data.
It really is a testament to the ingenuity of the engineers who design these systems. They've thought through all the challenges of big data and come up with elegant solutions.
So we've talked about architecture, performance, specific features, even load balancing. We're getting a pretty good sense of how these systems operate, but I think it's time to address the elephant in the room. Which one is better?
The age-old question. But honestly, there's no simple answer. Both Pulsar and Kafka are incredibly powerful systems with a lot to offer. Choosing the right one is all about understanding your specific needs and priorities.
Okay, I get that there's no one-size-fits-all answer, but could you give us some guidance? What are the key factors to consider when making this decision?
Of course. First, you have to think about your organization's structure and needs. Does your organization have multiple teams or departments that need to share the same messaging infrastructure? If so, Pulsar's built-in multi-tenancy could be a major advantage. It provides that built-in separation and isolation that can make managing a complex system much easier.
That makes sense. So if you're working in a large organization with multiple teams, Pulse might be the way to go. What about performance? Is there a clear winner there?
Well, as we saw from the benchmark results, Kafka can have a significant performance advantage in certain scenarios, especially when it comes to raw throughput. Its simple, streamlined design really shines in those situations. However, keep in mind, those benchmarks don't tell the whole story. Performance can vary depending on your specific workload and how you configure the system.
Right, and it's not just about raw speed. We also have to consider things like reliability and fault tolerance.
Absolutely, and that's where Pulsar's decoupled architecture and reliance on bookkeepers come into play. Bookkeeper's consensus protocol, with its quorum writes and reads, offers strong guarantees about data durability and consistency.
So if data reliability is your top priority, Pulsar's approach with BookKeeper could be the more appealing option.
Exactly. And then there's the question of ease of management. Kafka, with its integrated approach, can be simpler to set up and operate, especially if you're not dealing with a multi-tenant environment.
Whereas Pulsar, with its separate bookkeeper system, might require more specialized expertise to manage effectively.
That's right. So you have to weigh the benefits of flexibility and scalability against the potential increase in management complexity.
This is a lot to consider. It's definitely more nuanced than just saying one system is better than the other.
It is, but I think that's what makes it so interesting. There's no easy answer. And the best choice really depends on your unique circumstances.
Okay, so no clear winner in the overall sense, but let's dive a bit deeper into some specific technical details. We talked about message persistence earlier. Could you elaborate on how those different approaches actually play out in practice?
Sure. With Pulsar and BookKeeper, when a message is published, it gets written to multiple bookies to ensure redundancy. BookKeeper then uses a quorum-based approach to determine when a message is considered durably stored.
Okay, so that quorum thing ensures that the message is safely stored in multiple places. What about Kafka?
Kafka, on the other hand, relies on a simpler approach. Messages are appended to segment files on the broker's disk. These segment files are then periodically flushed to disk, ensuring that the data is persisted even if the broker crashes.
So Kafka is going for a more streamlined approach, relying on its efficient storage and transfer mechanisms. Are there any trade-offs there?
Well, with Kafka, you have to carefully configure the flush settings to balance performance and durability. If you flush too frequently, you can impact performance, but if you don't flush often enough, you risk losing data in the event of a crash.
That makes sense. It's all about finding the right balance. Now, another area where these systems differ is in how they handle message ordering. Can you explain what that means and why it matters?
Certainly. Message ordering refers to the sequence in which messages are delivered to consumers. In some applications, it's crucial that messages are processed in the exact order they were sent.
I can imagine that being important in things like financial transactions or inventory management. You wouldn't want a withdrawal to be processed before a deposit.
Precisely. Now, Kafka guarantees ordering within a partition. So if you publish a sequence of messages to the same partition, they'll be delivered to consumers in the same order.
So the key is to keep related messages within the same partition. How does Pulsar handle message ordering?
Pulsar takes a slightly different approach. It guarantees ordering within a topic, but not necessarily across multiple partitions within that topic.
So if you need strict ordering across all messages within a topic, you'd need to ensure they all go to the same partition. That sounds like something to keep in mind when designing your messaging strategy.
Definitely. Understanding the nuances of message ordering is essential for choosing the right system and configuring it correctly. Now, another interesting aspect to consider is how these systems deal with message retention. How long do they keep messages around after they've been delivered?
That's a good question. I imagine there are reasons to keep messages for a while, but you wouldn't want them hanging around forever, taking up space. How does Kafka handle this?
Kafka allows you to configure retention policies at the topic level. You can set time-based retention, where messages are automatically deleted after a certain period, or size-based retention, where messages are deleted once the topic reaches a certain size.
So you have a lot of flexibility to control how long messages are kept. What about Pulsar?
Pulsar offers similar retention policies, but it also has the concept of message expiry. You can set an expiration time for individual messages, allowing for finer-grained control over message retention.
So if you need to ensure that certain messages are deleted after a specific time, regardless of the overall topic retention policy, Pulsar gives you that option.
Exactly. It provides that extra level of control that can be valuable in some use cases.
This is all really helpful in understanding the subtle differences between these systems. It's clear that both Pulsar and Kafka have put a lot of thought into their designs, and they each have their own strengths and weaknesses.
Absolutely. And as we continue this deep dive, we'll uncover even more of these fascinating details and nuances.
I'm ready for more. What else do we have on the agenda?
Well, let's talk about some of the more advanced features these systems offer. Things like message deduplication, dead letter queues, and schema registries.
Those sound intriguing.
Yeah.
I'm all ears. All right, so we've covered a lot of ground already: architecture, performance, even load balancing. But you mentioned there's still more to explore, like some advanced features, like message deduplication. That sounds pretty useful.
Yeah, it certainly can be, especially in situations where you need to ensure that messages are processed only once, even if they're delivered multiple times. Imagine, for instance, processing financial transactions. You wouldn't want a payment to be processed twice just because the message got delivered twice by accident.
No, that would be bad. So how do these systems tackle this deduplication challenge?
Well, Kafka offers something called idempotent producers, which assign unique identifiers to messages. If a producer tries to send the same message multiple times, the broker can detect the duplicate based on the identifier and discard the extra copies.
So it's like having a tracking number for each message. That makes sense. Does Pulsar have a similar mechanism?
Pulsar handles deduplication a bit differently. It relies on the concept of message IDs, which are also unique identifiers assigned to each message. But Pulsar's approach allows for deduplication not just at the producer level, but also at the consumer level.
Oh, that's interesting. So even if a message is delivered multiple times to a consumer, Pulsar can prevent it from being processed more than once.
Exactly. This can be particularly useful in situations where consumers might experience failures or restarts and need to replay messages.
Right. Makes sense. Deduplication definitely seems like a valuable feature for ensuring data accuracy and consistency. Now, you also mentioned something called dead letter queues. What are those all about?
Dead letter queues are like a safety net for messages that can't be processed successfully for some reason. Imagine a message arriving that's malformed or missing some crucial information. The consumer might not be able to process it, and simply discarding it could lead to data loss or inconsistencies.
Okay, I see the problem. So instead of just throwing those problematic messages away, what happens?
Instead of discarding them, these messages are sent to a special queue called the dead letter queue. This allows for a later inspection and potentially even fixing the issues that prevented them from being processed in the first place.
So it's like a holding area for messages that need special attention. That's a
Yeah.
pretty clever solution. Do both Pulsar and Kafka have this feature?
They do. Both systems provide support for dead letter queues. Recognizing that handling message processing failures gracefully is essential in real-world applications.
Yeah, it's all about having those backup plans and fail-safes in place. Now, there was one more thing you mentioned earlier, schema registries. I have to admit, that one sounds a bit mysterious. Can you shed some light on what those are and why they're important?
Of course, schema registries are all about managing the structure or schema of the data being passed around in messages. Think of a schema as a blueprint that defines what fields a message should contain and what data types those fields should have.
Okay, so it's like a contract between the producer and the consumer,
Yeah.
ensuring that they're both speaking the same language.
Precisely. And a schema registry is like a central repository for storing and managing these schemas. Producers can register their schemas, and consumers can retrieve them, ensuring that everyone is on the same page.
That sounds incredibly useful, especially when you have multiple teams working with the same data. Do both Pulsar and Kafka support schema registries?
They do. While neither system has a built-in schema registry, they both integrate well with external schema registry solutions, like Apache Avro or Confluent Schema Registry.
So it's more of an ecosystem play, leveraging existing tools to enhance the functionality of the messaging system.
That's right. And these integrations highlight how important schema management is becoming in the world of data streaming and messaging.
This has been a really insightful deep dive. We've covered so much, from the basics of messaging to the complexities of architecture, performance, and even these advanced features.
Yeah, it's been a pleasure exploring these systems with you. And what's so fascinating is that we've only just scratched the surface. There's a whole universe of knowledge and detail waiting to be discovered within these systems.
Yeah, I'm feeling a bit overwhelmed by all this information, but in a good way. It's amazing to see the depth and complexity involved in something as seemingly simple as message passing.
And it's a testament to the brilliance of the engineers who've dedicated themselves to building and evolving these systems.
So as we wrap things up, what are the key takeaways for someone trying to navigate the world of messaging systems?
I think the biggest takeaway is that there's no silver bullet. Both Pulsar and Kafka are incredibly powerful and capable systems. But the best choice depends entirely on your unique needs, priorities, and the challenges you're facing.
Yeah, we've seen how there are different architectural approaches. Pulsar with its decoupled design leveraging BookKeeper, and Kafka with its integrated simplicity lead to different strengths and weaknesses. It's all about understanding those trade-offs and choosing the system that aligns best with your requirements.
Exactly. And beyond the architectural differences, we've seen how both systems offer a rich set of features and capabilities, from multi-tenancy and consumer groups to sophisticated mechanisms for message persistence, load balancing, and even handling failures gracefully.
It's clear that both Pulsar and Kafka have a lot to offer, and the choice between them isn't always easy. But I feel like we've gained a much deeper understanding of what makes these systems tick and how they can be used to solve real-world problems.
That's what these deep dives are all about, empowering you with the knowledge and insights to make informed decisions. Now, one final thought to leave you with as you continue your exploration of this fascinating world.
Always love a parting thought. What's on your mind?
As you delve deeper into the technical details, remember that these systems are constantly evolving. New features are being added, performance is being improved, and the boundaries of what's possible are constantly being pushed.
So it's an ongoing journey of discovery and learning.
Exactly. And it's a journey that's well worth taking. Embrace the complexity, stay curious, and who knows what amazing things you might create with the help of these powerful messaging systems.
On that note, thanks for joining us on this deep dive. It's been a real pleasure.